The thing does have a print on. I just saw it. Private. That's a private member. That's the reason. I guess this one should continue. Maybe we should change both into two. It's a line piece. Yeah. That doesn't work for some reason. It's expressed in center, start and end angle anyway. Hmm? Wait. We can use two directions. Yeah, we're using this direction. It's not good. Should use this direction. It's the direction of P1 minus P0. Yes. There's a positive angle, and then like this, it's a negative angle. But it also, it's always drawing it counterclockwise, so then instead of doing this, it draws it like that. And then this is the other angle, starting angle. This is always positive, because it's negative you don't have a curve. So it's positive here. No, wait. This is the order. Oh yeah, Ninja. No, I want to have the angle in radians. Can I get that from the arc? I think so. Can only get those two. So the difference is of course always the same. It is this angle. Let's calculate that separately. Right. Now it should be possible to construct this curve here from, well, this angle, blue angle, and this direction, of course. Maybe we should work with the angle here as well. This angle here. That's also what I'm doing here for this curve. So then we have the start angle and the end angle. It's just going that way. What? What the hell is that? It's a book. Shit. Hmm? Why is this not looking like what it did look a second before? Did I miss a minus sign or something? No. Great. Now it's cooled off. No, there's a minus sign. Yeah, that's all buried in intersection. Apparently the order is not as I expected. And I'm overriding the wrong one. So how easy is this to detect? What the hell's happening here? It's like if extend is unequal to. What about both? I have a none. You have a none and a both, so something's wrong here to begin with. So extend means that the coordinates that are being passed should be extended until the intersection with the bounding box. So I want to override it. I want to override it if it is extended. So I should do an and then override it if the bit is set. So if 2 is set, then I want to copy, let's say, the 2 in extended 2 index. Extend the 2 coordinates onto that index. Yeah. This is then just the opposite. It has to be the opposite. And then this depends. Either it's 0 or 1 depending on the actual values. Let's try 0 and 1 both, see what the result is. I mean, neither will be good, but Can I not do that automatically, like int or something? So just compose. Well, that's strange. And this does not work either, I suppose. Not using static cost here. So why would static cost not work then? Tried static cost. Failed operance of binary expression, Linux. Oh, never mind. You have to cast both. Yeah, it's too dirty this. I don't want to cast all over the place. Well, that's new. Oh, wait a minute. Now it overrode these coordinates with these. What? That's unbelievable. What I want is to override these coordinates with these. Yeah, true. So this is what we had then, or they didn't really change anything. No. Totally not what I had. I mean, this now is wrong, but this one's also changed. Now it overrode this one with those, which is when I want to extend from, but I want to extend to. So I need to change this. Oh boy. So now this one is correct, but that one is wrong. Then this is what we had before. Yep. And then I have to figure out if it is a 0, it has to be 0 or a 1, which depends on I guess the sign or the dot product between that and that. Something is less than 0. 0, otherwise 1, and maybe the other way around. And then this is the dot product between the differences. Well, I have the differences here. So that would be dx times another difference plus dy times another difference. The difference being del x No, both wrong. So apparently it should be the other way around. Okay, so now they're okay, and then hopefully I can not break it. No, it seems to work. Right. It's called bounding rectangle. But yeah. Should fix that the cue points are moving along. Impossible. Why did I move that one, I suppose? Yeah, okay, let's draw the tangents here as well then. Why not? Ish. It's kind of missing something here, right? Can't draw a half line. Would have been nicer, I think, if I had an arc with an arrow. You can just form here and then an arrow there. And then here I can just draw it the other way around. Have an arrow there. Instead of always clockwise and then get these long things. It's really a negative rotation, this. But well. So now I want to find the, I think just the velocity in point 0 as a function of the two green angles. Now this green angle obviously determines the direction, and then this green angle should determine the length of the velocity. There's a high velocity, it's a very high velocity, and here the velocity goes to 0. I wonder if maybe I should use control point in this case. Control point is now here. And the other one is here. So you can go from both angles to control point, and then from the control point it should be easily it is easy to get the velocity. It's never simple to know what is. It's never easy to know what is the most simple thing, mathematically speaking. Let's start as line style, I guess. Curve line style. Clearly I have no idea what I should do now next, so I'm just doing nothing. Beautifying my graph. Yeah, I still wish I had arrows there. Also, it's, yeah, I don't know, very white, the background. Can change that as well, but then you can't see the gray anymore. Should make a to-do list, because there are certain things that I should do, want to do, but I don't want to do them now. I think I made Kotaro mad or something, because he hasn't shown up. I don't know. It's a word. Different opinion on what is a Bezier curve. An argument almost. Yeah, not enough sleep as usual. Okay, I need to decide with formulas again. I hate that because I can't do that on my monitor. Actually, I can probably, but pen and paper is a lot easier. Mm. Mm, 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 mm. So the reason I started using arcs here or angles is that now it's just a single variable. If I have red and green here, but this is a fixed corner, so red is always fixed angles, or red is always a fixed value larger than green. And then it should be possible to minimize the total bending energy and plus elastic energy by changing that single variable, but then influencing two curves at the same time. So it's not just that I want to be able to construct a curve, but from there we want to go to the elastic and bending energy of the curve and be able to minimize it. So I need formulas in terms of, and then the points, they are fixed, that's nice. So just the angles here are then variables for the Euler-Lagrange equation in order to find the minimum. I really hate to use angles though. Angles. That's so trigonometry, right? Well, I want to only have to deal with linear algebra, vectors and stuff. There's nothing linear about this. I mean, the bending energy has an arctangent in its tangents. What how you pronounce that? And the elasticity has a elastic of the stretching energy has a natural logarithm in it. Not to mention the third degree polynomials. Let's see if we can run, what was it called? I have no idea. Lex, no. 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 Thought it was something with 3 letters, and I can't remember it. Lex. This doesn't even help me. Because, yeah, all nice and dandy, but it doesn't show me what it is. How do I show what it is? Update, navigate, insert, view. Edit. Export. That was a way to render it. That worked, sort of. Can we move it? It doesn't really, not really like to be moved. Ah, okay. Now there we have the equation then, right? For the Bezier curve. Maybe I should call it a B there. So, oh no, I don't want that. So we go here and let's say I want to update this into a B, the B of Bezier curve. And then I can do update, Control Shift R. Let's see if that helps. Control Shift R. That seems to work. No, it's a B. Cool. Yeah, so we have a P1. I'm having the feeling I'm typing the same stuff over and over, but okay. Typed it a billion times before. P1 is then obviously P0 plus V0 plus frac of 1 over 2 times A0 dollar Control Shift R. Wow. Just filled in T equals 1. Yeah, and then it's always easier to, well, let's forget about that one. So I'm gonna subtract P0 on one side and actually call that Q. Why not a Q? Let's call this Q1. I think I did that before. And I have the angle between V0 and Q1. So this is Q1 from P0 to P1. This is the direction of V0. That way. And we have the angle between that. Yeah, and the only way I know how to go from, well, how to include an angle here is by using a dot product. Yeah, I close it instantly. I can restart it, of course. No. Right, so obviously we have that the dot product between V0. Is that a dot? I have no idea. C dot maybe. And Q1. Definitely not the right dot. Let's try C dot because I remember it vaguely. Yeah, center dot. So the dot product between these two is equal to the length of V0 times the length of Q1. times the cosine of my angle. Let's call that thing alpha. I'm not entirely happy though, because cosine is symmetrical in negative angles. So if we would put this thing there, then which of course gives a completely different velocity, even in terms of direction. Then how would I know that? Because, well, the cosine of the angle is then still the same. The dot product really gives the length of the projection of one on the other. So yeah, it doesn't matter if you, I don't know what the velocity is, let's say it comes still there, so an arrow here. Can draw the velocity in, actually. Maybe I should do that. Draw the velocity. That would be plot dot create connector. Connector is an arrow. What kind of styles do I all have? Connector style. And then, I have no idea, but anything that is logical should work. So I probably need to pass 2 points. Of course I need to pass 2 points. At the very least a starting point, which would be P1, 0. Nobody sees it, here's a 1. I think 2 points, so probably again, and then plus the velocity in oh, nobody knows what that is. Let's first get the Bezier curve. Two of this thing and then the V0. Well, the velocity is huge. So here's the arrow. That's the velocity. So then if you project that thing onto the P0P1, and then you still have to multiply it with the length of P02P1, which isn't 1 here. It's more like, I don't know, 1, 2, 3, 4, 5, 6. So it's 6 times longer, and that length is what you get. So yeah, it doesn't really matter if you put it on that side, and you get the same projection, of course. Well, I don't have a velocity now, but the idea is the same. In other words, taking the cosine makes me lose information. So this is not sufficient. That's why I hate using angles. Just throws away stuff, man. Yeah, I think I need the normal, of course. Yeah, we need the normal of Q1. And then I can just project it on both. Use that as a coordinate system. Thus, we put that there. Let's say we have an N1. I'll even define it. N1 is the is Q1 rotated 90 degrees. So I'll just define that as a vector having minus Q1. Does that work? I'll make it Y. Minus Q, no, plus Q1X. It's not entirely clear this way. What about that? Lessons in LaTeX. That's better. Swapped X and Y, put a minus sign there. Now it's rotated 90 degrees clockwise. That's N1. And then, of course, we can add dot product between V0 and N1. Which is then exactly the same thing. I mean, it is of course equal to the length of V0 times the length of N1, which is equal to the length of Q1, because I just rotated it, doesn't change the length, times the cosine of alpha but N was rotated, it must be the angle between V0 and N1. Which is then, I suppose, 90 degrees. That's pi divided by 2. So I think I have to do something like this, maybe. Which then is, I suppose, or plus. In the end run, we end up with the sine. Because I mean, this angle is the same as this angle if you take cosine and sinus from it. Is it? Isn't it? Yes, of course. It has to be. So the sine of this small angle is positive. Yeah, that would be this height here divided by this length. But if I project it on n is q1, which is again from P0 to P1 rotated 90 degrees, so n1 is here. So in terms of n1, we have here a projection that's negative. So I need to end up with a negative times n1 and a positive value times q1. Now the cosine is positive, for this small angle. So I need this in the end has to turn into minus the sine of alpha 0. Minus the sine, and then at least we did not lose information. Yeah. Cosine of alpha minus pi divided by 2 is the sinus. So that was correct. And what is then the next step? Well, I'm feeling that if now, yeah, if now we pick a length of V0, the length, so we just say, well, we know the length, then we know both that one, and therefore V0 is exactly determined. And if we change the length linearly, then both change linearly. So the direction of V0 doesn't change anymore, just the length changes. So these two formulas exactly determine the direction, as it should, of V0. And the only unknown left is the length of V0. So now I can try to express the other angle in terms of V0, the length of V0, I mean, and then we can solve the length of V0. Yep, so this is a green angle, the other angle here, let's call this one is alpha 0, let's call this one alpha 1. And then I have to write that as well in terms of dot products with Q. Well, this should be exactly the same thing, right? Except that it's not V0 now, and now it's, well, this one, which is V1. So I can do the exact same thing for V1, I think. Let me move this one up though. Can I do that? Cut. The miracles. What am I doing? Yes. Okay, do the exact same thing, but then a little bit different. Let's call this alpha 1, and then this is V1. And then again, copy. That's where the, oh no, it's Dutch. Okay, any Dutch listeners? That's where copy comes from. It was a deep joke. I'm not even going to explain it. V1, alpha 1, yep. Which is all nice and dandy, but what is V1? Let's put it here. I expressed a Q1. Okay, let's put it after that one. I'm having a V1, which is obviously velocity at 1. The velocity is obviously V0 plus A0t. So then at 1 is V0 plus A0. Now what? Oh, I missed both of them. Yeah, just the derivative of this is V0 plus the A0 times t. Fill in t equals 1 and then you get that. So we can fill this in here. And then I get, in both cases, absolute horror. Man, I'm going to completely edit it here. Or not. It ain't easy, is it? It ain't easy. I can replace A0 here with V0 like that, maybe. I don't want to get rid of A0 as quickly as possible. $A0 is 2 times Q1 minus V0. Then this can be written as, at the very least, something without A0. So V0 plus that one is the 2Q1 minus V0. I don't see it yet, but I can just start filling stuff in. Let's get rid of V1. I mean, what else to do? So I'm going to copy this one. And then fill in V1. Yeah, and again, for the other one. I don't like this length here at all. at all. Right, okay, we can work out this one. I still don't see it, not even close. So this is the dot product distribute, so this is 2 times q1 dot q1, which is the length of q1 squared. And then minus 2 times dot product between V0 and Q1, which we have here. Well, at least that get rid of any dot product then. So what did I say? That is 2 times Q1, the length of Q1 squared, minus not 2 times, just minus V0 Q1. So minus that part. So that's still correct. Yeah. No. And another one. It's the same thing, but Q1 becomes N1. The length of N1 is the same as the length of Q1. So place it immediately with Q again. So that is the same thing then, exactly the same thing. No, it's not, because Q1 dot N1 is 0. So actually this is this drops out. Yeah. Q1 dot N1 is 0. That's N1's rotation of Q1 90 degrees, so the dot product is 0. And then we have V0 dot N1, which is also not, this is a dot product, I'm an idiot. Another length was here, never mind. So it's just this one. No, this one. With a minus sign, so it's that without a minus sign. P0 Q1 sign. Imagine making a mistake. I'll just keep this, I guess, or this rather. Check it. This one again, 2 times Q1 dot Q1 is 2 times the length of Q1 squared. And then minus V0 dot Q1 is this, P0 Q1 cosine, and that equals, and I just copied it. And the next one was Q1 dot N1 is nothing. So we are left with minus V0 dot N1. V0 Q1 sinus, yep, and that equals still this. Now, what can we do next? Can divide this one by the length of Q1. This one too. Let's divide both by the length of Q1. Yep. Hey, A4. Yeah, I'm trying to work out what this Bezier curve is. If I only have alpha 0 and alpha 1, well, and Q1. So the only known known things are, well, I know P0 and P1, therefore I know Q1, and I know alpha 0 and alpha 1. So V0 is still undetermined here, but it must be possible to get an expression like V0 equals and then something with just Q1, alpha 0 and alpha 1. So that's what I'm looking for. Any help, very much appreciated. So I'll type it in. What I'm looking for is something function of Q1 alpha 0 comma alpha 1. That's what we want to know. And it should be possible because, yeah, Q1 is this vector here. It's a vector, yeah, Q1. And alpha 0 is this green angle, and alpha 1 is this green angle, and that completely determines the Bezier curve, and therefore the velocity. V0 is this velocity here, the orange thing. So here you change the angle, change the angle. I can't change the angle anymore because it felt left alone and it stopped working. So if you change this angle, then the velocity length changes, although the direction stays the same because, well, that's just this angle here determines the angle. The length is also changing here. So it is possible. to write it like that. But how? I don't have the length, because if you do, mean not like this, divide by the sine over alpha 0. I guess you can assume that the sine is not 0. Okay, anyway, if I would do that, and I still have a v0 on this side, so, no. No, not draw. In an X11, you know, you missed the in. Well, here there's an X11 window, and this is what I drew in it. Or past that point. I'm drawing to my heart's content. Now I want to analyze the mathematics of the Bezier curves. Because I have to use the meaning. I think I have to use the meaning of the alphas. There's a Q1 here and a V0, and alpha 0 is the angle between them. So I can probably say something. I can probably write this in a different way. Pen and paper it is, after all. Okay, well, I have a Q here, and then I'll make 2 Qs. And we have a V here. Subtract that. Parallelogram. Subtract it. So then this is the result, and I want to have the length of that. And alpha 0 is this angle. Okay. I think that it's quite obvious that we will end up with so I have to determine that A and B. And those then are exclusively a function of the length of Q1 and alpha 0 and alpha 1. Right, so if I can find one, then I can find the other, because then I understand how to do it. So let's try to concentrate on A. And then A must be equal to, well, I have to get rid of B then. So we'd say take the dot product with Q1 here. So if you take the dot product with Q1 on both sides, we have V0 C dot Q1. And then on the other side as well, so I have to divide that by the length of Q1. Oops, squared. And yeah, Q1 dot N1 is 0. So problem being that I don't know what V0 is, of course. Well, yeah. But I might know what V0 dot Q1 is. At the very least, that's given here. So now I only need the length of V0. So this dot product is known, okay, well known, I mean, that's this one. The length of V0, or is the thing? Yeah. Divide Q1, length of Q1 out of it. Yeah, I guess B is as beautiful or beautiful, simple. So let's write that down as well now. B is going to be obviously well, the dot product with Q, dot product with N1. So V0 C dot N1 all divided by take this one, dot product with N1, and this becomes 0. This becomes V0 dot N1, which I have, and here we have the length of N1, which is the same as A squared, which is the same as the length of Q1 squared. So again, divided by the length of Q1 squared. And then I can replace again the V0 dot N1 with this and divide the Q1 out. So divide the Q1 out, and this then becomes V0 is minus V0. That was divided out times the sinus of alpha. The sinus of alpha 0. Which makes incredibly much sense. Yeah, that didn't help one bit really. It's just what I had here already. But okay, it does kind of tell us that we have to concentrate on the length of V0 divided by the length of Q1. Oh, I don't see it. Come on, it can't be hard. Why is it so difficult? So as said in the beginning, alpha 0 determines the angle, and then alpha 1 should determine the length. But alpha 0, yeah, hi. Sorry you're not saying hello back. I saw you too late and then I thought, oh, I missed it and I didn't say anything. Josh, your math, Josh, can you help me here? I'm looking for this. Vector V0 is a function of the vector Q1 and the angle alpha 0 and alpha 1. This is everything I have so far. So Bezier curve is a two-dimensional, in a two-dimensional plane. So this is a vector of xy coordinate, say, equals that point P0, also a vector. V0 is a vector times the parameter t plus a half times a0, which is also a vector, times t squared. So we bring P0 to the other side because it's just, to get rid of translation of the whole thing. P1 is also known. These two are known, P0 and P1. So I'm calling the vector from P1 to P0. From P0 to P1. This is Q1, which is then of course equal to that because it's just filled in t is 1. P1 means that t equals 1 here and t equals 0 here. Logically, I mean obviously, because if you fill in t equals 0, then you get just P0. Not as obvious is that P1 is the same thing, but then with t equals 1. So then you get V0 plus half A0 for P1 minus P0. And then I thought, well, let's get rid of A0. You know, every variable is sucking, so A0 can be expressed now as that. Q1 minus V0 times 2. N1 is Q1 rotated clockwise, anti-clockwise, 90 degrees. So N1 is this vector. It's not hard at all. Really, it's not hard. Well, you need to know what the dot product is, I guess. Although even that is not very hard, but if you were here and you had pen and paper, then I could explain to you what the dot product is in half an hour, and then maybe an hour with exercises to get the hang of it. A lot of this easy stuff is like, yeah, get the feeling, someone explains to you something that is super easy. Then it's the first time you hear about it. So you don't know where to place it. It's so new, it's scary. And then you get the feeling that you don't understand it. While if then you repeat it and you repeat it, you repeat it, you repeat it, and years later you didn't learn anything else about it because you were already told everything about it. But now it's familiar. And then you say, oh, it's easy. So why can't a human just learn something new and immediately say it's easy? Even though it's unfamiliar. I always forget that somehow. I mean, there's a great whatever, and then well, that's cool. Yeah. Yep. Well, Josh, you can help me now. Just think about it. Me, I live in the Netherlands, in Europe. Oh, really? That's relatively not that far away, then. Thought you would be, from the other side of the planet. Which is also pretty close if you zoom out enough. Our planet is so small. I used to have this picture with, the way they, picture it in books. The sun and the earth, and it all fits on one page. But really, you have the sun, and then you have a very, very long nothing. Very, very long empty space. And then there is a really tiny sand, how do you call that? A grain of sand, and that's an Earth. I bet you can easily fly through our solar system and never notice Earth. So small it is. All the planets are very small, actually. Compared to the size of the whole solar system. Well, I'm bad at it too, because I have no idea how to continue this. I mean, it's clear that it is possible. Yeah, I mean, these two angles completely, this distance here, this vector here, I can move it around, so it's a vector. I cannot move it around anymore. What the hell is that, man? Every time I leave the window, I can't move it around anymore. So this vector from P0 to P1 together with this angle, can change the angle, and this angle, completely determines this curve. I mean, that's just a given. It's being drawn, doesn't say much, but it is exactly determined. So I also know the derivative of the parameterized equation as function of t, which we call the velocity, which is then this orange vector. So yes, the orange vector is exactly determined from the vector from P0 to P1 and these two angles. Now, express it. Express V0 as function of. So this one here. P0 is a function of Q1. Q1 is then from the vector from P0 to P1. The whole thing is, of course, translation invariant. If I move this around, then yeah, then the velocity doesn't change. So I'm expressing it in Q, this vector here, and the two angles, and I can't find it. I just can't find it. What the hell, man? Okay, hey, thanks for dropping by, Jess. Good luck with your homework. I'll see you. Maybe I'm gonna stop streaming because I'm just staring at my screen and I don't know anymore. I don't know what to do. Yeah, I use Arch as well and pitch. I hate angles. Maybe I should literally admit defeat and I could now calculate this point here, which is the control point. Having a control point, everything is solved as well. And that should be easy, right? Intersection, calculate intersection point here. Knowing this angle and this angle. I mean, come on. That should be super easy. At least then I have a formula. Because right now I have nothing. Let's ask Gemini. It's so easy actually that probably the AI even knows it. This is so grade 8. Sorry, didn't want to make fun of anyone, but working with values is stupid. Don't work with values. Work with symbols. Oh, fuck yeah, the velocity is... No, it's not. Is that exactly a factor of 2 there? This is the control point. Velocity is twice the distance to the control point. Let's draw half the velocity. See if it ends up exactly here. Wow. So in the dark again. Yeah, that looks like it. So the half the velocity points at the control point. So that's having the control point gives us the velocity, right? So, oh, that even remains so, yeah. Absolutely. Good. Very good. Very good. And we can find that with using the sine law. Yeah. This length. And then we're there. It's actually super easy, this. Jesus. Why is it so easy? Why? I already had that, right? Actually, the sine law is up this angle. The sine of this angle divided by that length or something like that is equal to everything else. That length. So I need this angle because I have that length. I thought Jiminy did something else, but that is what it should be. Okay, it's talking about the sine of C. Yeah. Yeah, okay. No, I missed this part, but that's what we should do, yes. Right, so let's not delete anything, but kind of start over. The length of, say, so what we have is that the half of the half of V0 is the length of this thing in that direction rotated by this angle. Hmm. Yeah, we're already there actually. This is the answer. And the length of V0 is now given by the sine rule. So maybe I should just do that. Because the length of V0 is known, namely 2 times keep forgetting this. Talk about AC here, so AB, I have to translate it to the real thing. AB is the length of Q1 times the sine of B that's the thing opposite of AC, which was that thing, so that is that angle, which is alpha 2. So going to, yeah. Divided by the sine of C, which is pi minus the 2 angles. Now, let's see. The sine of pi minus some angle is, of course, the minus sign of that angle. Isn't it? Oh, it's actually just the sine. Doesn't really seem to make any sense, this. So now I'm still not convinced. Is wrong. Anyway, then we get it's minus the sign of minus a minus b, which is in the sign of a plus b. Oh, good enough. Thus, this is the same as the sign of that plus that. And then we can fill that in. This already divided by Q1 drops out. So $A is V0 divided by that, so that is 2 times, oops, so do it as a frac, 2 times the sine, the cosine of alpha 0. Times the sine of alpha 1 divided by the sine of the addition. A equals V0, which is 2, times the cosine of alpha 0, and then divided by Q1 times Q1 times the sine alpha 1 divided by the sine of alpha. Yep. And this can also be written as probably something like in terms of cosine and sine. Of course, I can never remember that, and I'm not going to ask Gemini because, yeah, it made mistakes already. The sine of A plus B. Is that probably good. Okay, I like this one. It's the same formula. Okay, that's the sine A co with a bit level and swapped. Okay. A is frac 2 that, and then this was call it again. How is that possible? Sine. Okay, it's just sine of that times the cosine of that plus the cosine of the first angle times the sine of the second angle. Dollar. Called close to frick. Now let's simplify that further, as it were. Ha ha ha! Incantations, Boys Bunny. 2 frac cosine that's the same as this, eh? Cosine alpha 0. Yep. So I'm going to add the first one. Plus that. And then minus again, because, yeah, can't just add stuff and then divide by what we had here. Okay, should have put an A in front of it. Cosine alpha sine something, and then plus or minus same thing. And now this is equal, yeah, this is equal, no, this, it doesn't want to. This is equal to that. And this is equal to that, so this all divided by that is 1. And then we get I don't think that did help me anything at all. No, it didn't help. I probably should ask Mathematica to simplify it. Pretty sure there's some way to simplify it, but how, you know? This is already pretty simple. Okay, I'll just keep this. Well, this one then anyway. I don't know. Yeah. Okay. It is then. I don't know. Probably. Can't be simplified. And I need an expression for B. Well, B is the exact same as A, except under minus sign in front of it, and the cosine is a sine. So that becomes a sine squared then, instead of the cosine. No, it doesn't. Oops, that's a sine of all of a 0. But this just becomes a sine. Oh, and a minus sign. We'll make a minus here. Minus. So, like that. Okay, let's test it out, I would say. So, go back to the program. I'm going to move this to the side so I don't see the chat anymore then. Go, put it there. Oh, I still see the chats. And then we go to the program, and then I'm going to replace my current Bezier. So I'm going to calculate velocity. Vector Bezier. I don't have Bezier already. I have a V0, but that V0 comes from the calculated Bezier. Q1 is P1 minus P0. Does that compile? Nope, don't even have a P1. Plot P1 minus plot P0. Vector N1 is Q1 rotate 90 degrees. Double cosine is alpha 0 I need a cosine, I need a sine, and we need everything of both. Now let's just get the angle. Where's my angle? I think I have the angle because I created the arc already. Yeah, these. This is alpha 0, I think. Yeah, these two. Divided by the same thing. But well. I probably should do that. No. I've got a 2 here. Minus 2 times the sine of alpha 0 times the sine of alpha 1 divided by the sine of the sum of that. Okay. So I'm going to create my quadratic now, not from that, but from Bezier. Drum ruffle. Movie time if it works. Well, apart from this, of course. Value type void is not contextually convertible to bool. That's the one I want to call Let's reference V0. V0 is a vector. That should work. What is its problem? Oh, that it returns. It doesn't return a full yet. Yeah, okay. So that means what? So that might fail and this one doesn't. Interesting. I mean, that's not true. Surely it can fail. No. Well, almost. Yeah, totally not. Yeah, well, what shall I say about it? Made an error somewhere. It rotates along with it, but no, not really. This is a non-solution, or actually this is a solution. Not really, no. This is a solution. See, it works. And this one. I mean, the simplest of things, right? It's just taking off in the wrong direction. Simplest of things being that, of course, it should go tangent to the angle that I give you. It's going in the wrong direction. But at least if that angle is 0, then it goes in the right direction. But it's already taking off in the wrong direction. Looks like X and Y is swapped here. Not exactly, maybe. Not exactly. No, I put it there. That's not true. It rotates faster as well. The angle is like twice. It goes the wrong direction twice as fast as it should. But not really, because now it's definitely not factor 2 anymore. There's also beep. Oh, this looks nice. I mean, it looks nice because now it looks like... No, it doesn't. Well, here it looked like the tangent was correct. But if I move it away, it's just totally is not. If you move it further away, then you see that it's a little bit off anyway. It's not the tangent to this line. It is completely wrong. Damn it. Good night, Ninja. I'll see you. Yeah, I think it is just a matter of redoing everything again, but then correct. Let me begin looking at this again, if this is correct at all. If, well, obviously we can express any vector in Q1 and N1 because N1 is perpendicular to Q1. And then alpha 0 is the angle between V0 and Q1. Therefore, if this is 0, then cosine is equals to 1. We have something. We have the length of V0 divided by the length of Q1 times Q1, and B is 0. Totally correct, right? Totally correct. And if the cosine is a small angle, then left or right doesn't really matter. Then this just shrinks from 1, so that is still correct. And if the sine is a small number, small positive number, that should be a plus. Why is there a minus sign there? I thought it had to be a minus sign, but no. Alpha is also counterclockwise. That should be a plus. Started fixing that then. That minus sign is not there. What else should we change then? Just this minus sign, huh? It goes in the right direction now. Look at that. No, what am I saying? That's not true. Of course it goes in the direction of orange. It should go in this direction here, the plus. It's not. So it's still 0, it goes now, it rotates now twice. No, it rotates too fast here and then it slows down. Oh, then it switches to the other side. Yeah, no, of course. It's still bullshit. Nothing. Nope. The reason I say that it should not be a minus sign is because if the green angle is small, like so, small green angle, then the velocity vector should of course be in this direction, the dot 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 line where the angle points to. Then we have a small, like this, so a small projection onto Q1 and a small positive projection. Sorry, small, it's just almost 1, so this is the cosine of that angle. And we have plus the sine of that angle in the direction of N1, which points in that direction. So it definitely should be a plus cosine and plus sine. Yeah, well, that's that looks like dinosaur. Well, it should be that's yeah, exactly what I don't want. The dinosaur bug. Reminds me of a very interesting bug I found with my boyfriend in Second Life. It was called the seagull bug. There was something mysterious crashing sims. And we were the brilliant coders, so everybody happy when our sim started crashing as well. And then I could find it. I mean, we were like running our own server. Own sim, own server, everything, our own stuff. So I was able to debug the crashing. And the reason was that we had a seagull flying over the island, which flapped its wings by using flexi prims and then changing the Z coordinate of the seagull itself. So the seagull would go up, down, and then the wings would start flapping because it was like blah, blah, flappy. And then there was it was a super coincidence. Very hard to track down. Combination of the flexi and something else, and it's went down history as the seagull bug. I still miss good old times with him, man. Such a smart guy. Could really talk about everything. Mathematics, programming, equal level. We worked on some very interesting, beautiful, complex problems together. Well, yeah. What now? I have here V0 touch. Okay, so the plus and it must be plus, both. And then of course the sine is for the normal and the cosine is for the q itself. So that if the angle is 0, then it points in the direction of q. This is now correct. And if this is correct, if that is correct, well, it isn't, then I suppose this is also correct. I did use something else with that, I think. We'll just divide the q1 away in both cases. Yeah, and the 2 survives, and then we get sine alpha 1 divided by the sine of alpha 0 plus 1. And then the A has a cosine alpha 0 and the B has a sine alpha 0. Sine alpha 1, sine alpha 1. Yeah. So if this formula is correct, then these are also correct. Let's see if I copied that correctly. This is Can't check that. This is really counterclockwise, huh? Then the vector wrote the 90 counterclockwise. Yeah. And Q1 is also correct. Oh, wait a minute. No, this should be correct. Yeah, it's to from. Normally you do from to, but this subtraction was to from. So that's also correct. And then compare this formula. This is 2 times the cosine of alpha 0. Now both are arc01. That just means that it's the first between P0 and P1. And then this is alpha 0 and that is alpha 1. Divided by the sine of the sum of those. And here also a 2. And then the cosine is replaced with a sine. And the rest is also a sine. Yep. Times n1. Oh. 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 That's not correct. I added the second 2 times. That would definitely explain a lot. Try this one. Second bug has been found. No, still not good. Still, well, actually, now it does. Now it departs in the right direction. The beginning is now good. It's exactly laying on top of the tangent here. Yep, very good, very good. Except that it does it. It jumps here. I don't like that. But on the other hand, this is good, but that's not good. Nobody knows what's going on here. Oh, it enters from the wrong side or something like that? No, I don't know what it is. Yeah. I think it has the velocity the wrong way. So it's a straight line. If we do this, it tries to enter from the other side, which it should not. But right. Okay, so then this must be wrong. And that is what? That is... Could put a minus in front of it. Wahaha. Is that too random? This 2 just has to do with the fact that this thing here is twice as long as the distance to the control point. So we can see that as a half times V0 equals that. And then the sine rule is, of course, divide by alpha 1. So we have... let me run this thing again. We have this triangle here. This is Q1 and this is a half V0. Both pointing away from P0. then the sine rule says that the sine of this angle, no, this, maybe Gemini is wrong. Let's start with the sine rule, because I don't think it's wrong, but calculator. There it is. So it's the sine of A divided by A equals the sine of B divided by B. Where it would be nice to have a picture with it. Law of sines. Yeah, here we have something useful. Yep. So it's the sine divided by the sine of the opposite angle. They're all equal. So this length here, which is a half the length of V0, divided by the sine of this angle, equals this length, which is the length of Q1, divided by the sine of this angle. Well, I really think that that's this angle. Outgoing, incoming, plus, yeah, equals Q1 divided by the sine of pi minus. So if this is correct, then the absolute value of the velocity equals 2 times that the length of Q times this sine, still divided by the sine of pi minus those two angles. And then we can apply this. So it is that length divided by the length of Q1. Yeah, really, I can remove the length of Q1 then. So let's divide it by the length of Q1. Div Q1. Damn it. I'm trying to get the velocity correct here. So the orange thing here that goes completely off my monitor and the next monitor also is a bit too long. It should be like this long to the end here. That is way, way longer. Why is it too long? I don't even, that must be it, right? I mean, it ends here because the velocity, yeah, the direction is correct. This angle is determined by the velocity in 0. So if you get the length correct, then this angle is also correct. It should go like this. The black curve here, this one is correct. This black curve should go like and then there. So yeah. So it shoots off way too fast. So it overshoots and it comes back and then it has the wrong angle. So the velocity is wrong. Yeah, okay. But you mean one day I will come here? You're going away already? Not really eternal to teach C++. I'm just a C++ coder who is coding online. Not to teach anyone really. Why the hell is this wrong? Okay, the paranoia is setting in now. We're going to print everything. If you don't know anymore, Then just print it. Q1. The out DC notice N1 is N1. Could also just draw it. If I draw it, then I see immediately it is correct. Let's plot a connector. Create connector. Yep, so that's as expected. At least, you know, I'm assuming that this is N1 and this is Q1 and not the other way around. Mm-hmm. Really, I'm gonna turn on the lights. I'll be right back. Yeah, see, get out of my chair more often. What else? Now I'm walking around anyway. I'm going to get some water for my tea. Why is nobody doing the dishes here in the house? Oh wait, that should be me. Yeah. Tea. Yeah, I'm back. I'm back with krentenbollen. Ja. Oh, Q1 is a connector, yeah. Mm-hmm. That's not right. Now it is going in the opposite direction. Yeah, this is correct. Can't be a coincidence that is correct when this angle is 90 degrees. Oh, wait a minute. Plus and minus. No, not the minus. Let's make this a minus. Oh well, it was worth a try. Clearly not the right direction. I think I'm going to just try all plus and minuses until it works. Bloody hell. That one was right, wasn't it? It was right. Already decided that one was right. Finally, we got it. Whew. Okay, now it works. Yeah, I wasn't even really gambling. No, really, I wasn't. The problem is that I assumed that this was the. I mean, I have treated this angle equal to that angle. You know, we need a sine of this. No, we don't. We need this angle here, and then I did pi minus that angle, right? But then I used that angle, and this angle is actually minus that angle. So only where we were calculating pi minus this angle, which is equal to that angle, indeed. I had to do plus this angle instead of minus this angle, because that's the same as minus that angle. Yeah. And this is not the velocity, it's half the velocity, and it ends exactly in the control point here. And I had rotated my microphone away because I was eating something. Okay. Yeah, I might as well leave it like this. And then this if here, you know, can this not fail? Quadratic from. I thought about that before. I guess it can't fail. Yeah, it can't fail. That's really weird, actually. Right, let me keep that on. So that means that now suddenly, no matter what I do, it works? No. If I drag this over here, there's no solution. So probably I get a velocity which is wrong. Try that. Oh, but yeah. So it ends in P1, but now the entry point is from the wrong side. So should reject this solution. Here also it goes in the other way. No, this one is correct, but that one is wrong. It just flips directions as it pleases. Both are wrong. Both are correct. One is wrong. The other one is wrong, and both are wrong. So how do you detect that? It's of course quite important because I want to minimize the length. And then I don't want to, well, minimize the bending energy and the length, or a balance between those two. And then I don't want to end up with a curve like this because it's using less energy. Yeah, it's not really a good curve. This would never result in... Well, actually, that's not true. This is allowed, but then this one must flip as well. So as long as I'm not dragging this thing around, it's not allowed. So I drag it to the other side, then it should be correct again. Yeah. How the hell do I detect it? Yeah, it's the control point is what I'm really calculating, which is the coordinate, or sorry, some factor times the tangent. Wait a minute. Yeah, I don't have that. Damn it. We have Q. I mean, I should reject this one because the green thing and the orange thing point in the different direction. And likewise, we have a green thing here, and I should also be able to draw a velocity. In that case, they should point in the opposite direction. Or no, they shouldn't actually. So I should... This will must be there as well. Now I do know the velocity, but for the green point I only have an angle, this angle. And the angle is relative to Q1. Alright, this flipping point happens when this angle is a little bit larger or smaller than that angle. So if we put it like this angle is larger than that angle. Therefore, the intersection of these two lines is like way down here. That then is wrong because the angle is small. But it's larger, so if both would point in this direction, and now it is correct. No, it's not correct. No, this one is still wrong. I should not rotate this one. Yeah, now this angle is also larger than that angle, but way larger. So what about if I just subtract pi from this angle? Is it then still larger or not? So if they are equal, yeah, it is just larger. If they are equal, then these two are parallel. I mean, this thing minus pi is equal to that one when these two lines are parallel. So it always, this is counterclockwise, gets larger. So to have an intersection point on this side, it's always that this angle must be a little bit larger. Therefore, it can only be a little bit larger if it points in this direction, which means that this angle is larger than when is the other flipping point then? Oh, here. No. Yeah. And it goes through that point. To the left or right. That simply has to do with basically this angle being positive or negative, or the sign of that angle. The sign of that angle is positive or negative. Then the entry point here switches. Now it comes from below. If we put it on the other side, then it comes from above. And then how long does it come from above? It comes from above until it gets, this angle gets larger than that angle. So this is between 0 and that angle is something. What happens if I make this angle then way larger? Is that then also way larger? So here it comes from the opposite direction of the green point. And then if I pass through it, it comes from green, so that's wrong from this point here. And then we can go all the way till, yeah, all the way till here, till they are parallel. And only when we get larger, it swaps. That means that everywhere else it comes from this direction. Huh? Yeah, no, it doesn't. It swaps again here. But. So this is the same as that. Man, every time I think I analyzed when it is correct and when I should reject the solution, it's different again. The easiest would be if I had just had these direction vectors, really. But, yeah. That would be so black boxy, you know. Like, I would still find all the solutions and then, for seemingly unrelated reason, reject. If you that's not going to be very nice to work with. Mm-hmm. What's that? What the hell is that? Division by zero, maybe? Oh, well. Let's make an automatic rejection for the moment. I don't think I see it, so brute force. I will need the direction vectors. It's just these vectors, or well, the direction to that point for both. So that would be D1 and D0 and D1. Already have that. And then the dot product with the velocity must be positive. Ach, arg. Ja, dat is nonsens. So. Those should also be rejected when the velocity at V1, of course, is dot product with D1. Which, unfortunately, I don't know. Well, I know it inside there. Let's move the whole thing inside. Oh, huh? This should be black. Oh no, yeah, sorry, this the velocity could also be less than. Oops. That's correct, and everything else is wrong. That's correct. Yeah. No, I should make a 2D plot, maybe with all angles on both sides. And then see when it should be rejected or when it is good. That ain't easy. So I just need arc. I just change the arcs. Then this is correct. Therefore, this is correct. These are static. But it still depends on Q1 and N1, of course. Or doesn't. No, it shouldn't. No, it shouldn't. It should not depend on that. It's interesting in itself. I can test that too, but okay, let's keep them fixed for now. Calculate, check, reject. Yeah, that's it. Yeah. Might as well just print it immediately, maybe. 100 characters. Can I print it? I think so. What the hell is that? Too much debug output. Entering Bezier curve quadratic form. Yeah. I can suppress these. Wait a minute. I can suppress these, but once I'll turn the notice off completely while inside this loop. Oh, so that's why I didn't get it. Still not clear. This is far from clear. What the hell is this? And this random stuff here? Same here. Yeah, well, at least now I see why I didn't get it. It's far from trivial, man. I still don't get it. What is this? I don't think it should depend on, you know, the position of these two. We just rotate this one over. Oh yeah, that's not gonna work. Oh wait, maybe this. Oh. Oh yeah, definitely changed. Totally changed. What the F? How is that even possible? How is that possible? So no idea what is going on here. No, it's too much work for one person. In terms of programming, I can do it, but I don't have time for it, and you need to know a shitload of hardware stuff, which of course I don't. It is. What? Why? Why does that image change if I rotate P1 somewhere else? It should be completely a rotation invariant, man. It's not possible. Not possible that makes a difference. It's not possible. think I'll just plot it in this thing. It's 10,000 points, right? To be possible. So I do horizontally from 0 to 2 pi, this angle. And here from 0 to 2 pi, this angle. And then I can just drag this around. And if it can keep up, then it can probably not keep up. Okay, let's do something super fancy. Step 1. I need a function that converts an angle into a value between -10 and +10. Could do it in one go. And then I need my double loop again. Don't print this, of course. But let's suppress debug output still, because it's just too much. I don't think I need a table as well. Nothing? No, I don't get that. Why nothing? Jesus. Hmm? Now let's change the color. What is the color of my point style? Yeah, I don't know. How would I know? What is the color index bloody thing? Yeah, I hate that so much. Really have to change that. Really have to change that. Yeah. Point style does not have this, or what? Not sure it does. Just copied it. That's what I mean. Two colors that are almost the same. No. Draws fast enough, but erasure is, wow, slow. At least now I see some structure in it. So at 0 there's a vertical line. And maybe here as well. And then we have these diagonal lines. Here one, and here. The good one, yeah, I mean, this is like, well, it's not 4 times the same thing. Don't tell me I'm going from minus 2 pi to plus 2 pi. Yeah. No, 0 to 100. The angle goes from 0 to 2 pi. Okay. Let's go from minus pi to plus pi. I cannot draw it anymore, this nonsense. Yeah, I was looking at 0, but that wasn't 0. Runs from 0 to 2 pi. I want to draw even more. I mean, it's maybe ridiculous. Now it gets how much? 100 times slower. So erasure is no longer there. No longer an option. But, well, we can still see something. Uh-huh. It looks like it's safe to say that this is 4 times the same thing, right? 4 times the same thing. But what happens if we move stuff a bit? That is... 1,000,000 Bezier curves. Definitely still 4 times the same thing. Although it beats me why there's so many noise in it. So much noise. Like, yep, pixel down. This line here, what the fuck? I mean, we don't see that here. Scary shit. Or maybe that's because I'm plotting something. I don't know what I'm plotting actually. I think I'm plotting crosses. So it depends on who is first. Blue is, I mean, they override each other. I should be plotting single pixels almost. So I think it's pretty safe to say it's 4 times the same thing, and then more or less, you know, block here and stuff. This interesting gap here, a little triangle. No, it's not a triangle, just this thing here. If you fill in this triangle with blue, then it's really simple. Zero to pi. No. I want to see what happens if I subtract pi from this. That should not make a difference, should it? Yeah, they did not make a difference. Very good. Right. Point. Draw point. So I can't set the size, right? Why can I not set the size? Oh, this is the size. It's either 4 or 5. Yeah, well. It should only go from -10 to 10. It begins again here, right? So I accidentally continue anyway. I think this is the end here. Yeah, it goes larger than 10. What the hell? Larger than 10. That it would do that if angle goes beyond m pi, right? Yeah. Should go from 0, then this is -10 to pi. Why the hell would this go beyond pi? Oh, because it's bloody still 500. Yeah, okay. Yes. This makes sense. Well, I mean, doesn't make sense, but what the hell? What is this? You know, what is this? What does this? How is this determined? I have no clue whatsoever. Really. Next thing to do is put this one layer lower, I think. Put it in its own layer. What is this? What the hell? Yeah, I need a way to destruct the whole layer at once. This is definitely too slow. I think this diagonal here is definitely a diagonal, right? That's where the angles are the same. But the horizontal line here and the vertical line here, they shift as function of where P1 is. I really don't understand that. How is that possible, man? That's not possible. Why? How? Or is it just because the distance, maybe the Q distance changes? Does that make a difference? No, it should also not make a difference. It should be completely invariant for translation, obviously, but also for scaling and rotation. The angles are relative to Q1. Oh, wait a minute. Yeah, no. No, wait a minute. Oh, okay, yeah. I'm an idiot. Never mind. I'm a complete idiot. I'm inputting. No, I'm not a complete idiot. Wait a minute. No. This is angle here from 0 to pi relative to Q1. So 0 is here, and then you want pi till there. So if we rotate Q1, it shouldn't make any difference. No, should not. I don't understand why this shifts. Therefore, I'm going to do something very ingenious. I am going to do this exactly once, and then allow me to drag the thing around and show where I am in the graph. Rejections should be done once. Let's keep those then. Is in outside this loop here. No, it does it only once. Yep, and now I can drag this. I'm not drawing my curve now. That's maybe not what I want. Actually, yeah, I want to duplicate all this code. Nah. So now I can still drag them. And now I need to draw a point where we are. So you can do that also here. Do it at the end. Else. Angle point. Angles point. Need a red point. Nobody knows what red is. I don't know. Oh, there it is. That is a shitty color, of course. Gray. Where is it now? Oh, I'm going outside of more than pi. So less than. Oh yeah, of course. It doesn't even work correctly. So I go from this color to that color. It is not different. What the F? Nope, not working. So at least reddish. But still not changing color around this spot. Here it is changing color. But it stays red. Oh, no, it disappears. That's not possible. Hell, man. It's here. That should be negative, which is impossible. It's less than pi. Why can it never just work? Alpha 1 is less than 0, add pi. After which it will not be larger than pi, because it was less than 0. So I don't subtract pi anymore. Don't tell me I have to do a while less than 0. That's ridiculous. I must have pressed some button that I did not want to press. Oh, caps lock. That was clear. Okay, undo. Let's see. Okay, let's make it very clear that it is wrong. Oh, great. Minus 12. Yeah, so the angle is negative, which is not allowed. Up. Alpha 0 is positive and alpha 1 is negative. Why? If alpha 1 is less than 0, add pi. So apparently it has been less than minus pi. I don't know. Is that possible? No, it's not possible. It's never negative at all. Well, actually it is when this is negative. Yeah. It doesn't work, Post Bunny. It just how can I go to bed when it doesn't work? Alpha 0 is arc 010. Yeah, okay, nice. Well, I mean, really? Less than that? I don't understand why that would happen. Less than minus pi. Why the hell would that ever happen? Oh, wait a minute. No, well, adding pi is weird, right? I should add 2 pi. But no, not really, because we repeat every pi. I want to stay in that block there. But that's, yeah, normally you add 2 pi, and then on top of that, I want to kind of have a modulo pi, if that would exist. Okay, I'm just gonna do a while then. Yep, no, at least swaps there. But it doesn't change color. Why? Why does it? Why not? So it goes from light from cyan to whatever it is, and then this thing doesn't change color. Failure. I completely lost it. Where did my thing go? Oh, there it is. Okay, it changes color here at least. That's something. Does not change color here. Change color here. It's weird, man. It's impossible. Yeah, I should go to bed because it's just getting too late. But yeah, it's bullshit. That's what it is. So I wanted to interpret the color difference here, this color and this color, but then now I draw this red cross here. It's functional of what actually is doing here. So if I put the cross at the edge of those two colors here, then this one should change color, but it stays red. So that's why I cannot interpret this block, because it isn't there apparently. It is not there. Here it should swap. Oh. Oh. Okay. So the whole mod pi thing is nonsense, actually. Yeah, of course it is. So I can't do that, and that is just wrong. So let's start with removing the mod pi. That would be very confusing if it can't work. Mod 2 pi is possible. Let's force it to be between 0 and 2 pi. Yeah, really, and it should be enough. No? Yeah, of course. Like this is ever going to happen, but well. Two point zero times 2 pi. Less than 0, add 2 pi. Larger than 2 pi, subtract 2 pi. Yep. And then convert that the correct way, as in if angle is 0, I want to get -10. And if angle equals 2 pi, I want to get +10. So that work should work. Which is alpha 0 and 1, which are set here as something times pi divided by 250. So this runs from 0 to pi. Not good. Let's run to 2 pi, from 0 to 2 pi. Yeah, now I get this again. And again, it does not change color when I cross it. Unbelievable. Yeah, it switches here. Nothing to do with what I see below that. Oh, I don't get it. I don't get it. It's so weird. Okay, that one makes sense, but yeah, that's exactly at the 0. That wouldn't work. Yeah, so no change. That one also no change. Now here's a change, but it's so impossible. It's completely impossible. Possible. only the color is different. No. Right? Hmm. I think I understand what I'm doing wrong. Yeah. Okay. Yeah. The usual complete stupidity did hit me again. I know what I did wrong. How to fix it? I have to subtract the Q1 angle. Let me see. I use this direction. Q0 minus P1. Is that what? Something. That's that direction. These. Shit. So. What am I doing wrong? No, this is not. This is also not good. Nope. No. Mm-hmm. Yeah, I'm going to bed. Guess I'll fix it tomorrow and then once. Don't get it. Seems impossible. That is, I'm running over all possible values of alpha 0 and alpha 1. That is all possible values from 0 till 2 pi, if I'm not mistaken, as long as that is set. And then I use the exact same code to calculate if it is to be rejected or not. And then I convert that alpha 0 and alpha 1 that I used to calculate the reject to calculate an x and y coordinate, and then we plot a point at that point with a color that depends on the rejection. And then after all the rejections have been generated, I drag those circles, which only changes these two things. And here, yeah, now this is false. So I'm just using those values. Instead, calculate the rejection for those angles. We should use the exact same code as well, but it's not pushed back, but stored on the layer. But okay, now I'm doing that here. It should be the same thing, right? The only problem is that maybe it's outside of that 0 to 2 pi range. But this can't make any difference. Just adding or subtracting 2 pi. Why? Why does it change color here? Well, there is absolutely nothing. It's just completely wrong. It's completely wrong. The reason it's wrong is because the green crosses here. It goes in the opposite direction. So it should be there. Now it's good. And now the thing is nowhere to be seen. That dot. It's negative value. At least, at the very least, this should not be there. I don't get it. Possible. Yeah, okay. Good night, people. Thank you for hanging out, as it were. Especially Post Bunny, who is actually hanging out.